Chapter 8, Foundations of Coding, Mastering the Basics. ThinkBot. Jia. Jia, hi. I'm really excited to start coding, but I'm not sure where to begin. Can you help me understand what I need to do before I start writing actual code? ThinkBot, of course. Before writing actual code, there are a few important things you should do to make your coding journey smoother and more successful. Jia, great, I'm all ears. What's the first thing I should do? ThinkBot, the first thing you should do is plan out what you want to create. Break it down into smaller parts or features. This will help you organize your thoughts and give you a clear direction. Jia, got it. Planning is key. What's next? ThinkBot, once you have a plan, the next step is to choose a programming language. The language you choose will depend on what you're trying to create and your personal preferences. Jia, that makes sense. But how do I actually learn the language? ThinkBot, you can find online tutorials, courses, and resources that teach the language step by step. Many platforms offer interactive coding challenges that can help you practice as you learn. Jia, practice makes perfect, right? What's after that? ThinkBot, absolutely. After you've grasped the basics of the programming language, it's a good idea to start with simple coding exercises. Jia, coding exercises, got it. ThinkBot, okay. Let me help now to start with the prerequisite before you actually start writing a program or do coding. Coding and programming. Coding, also known as programming, is the process of writing instructions in a programming language to create software, applications, websites, and other computational solutions. These instructions, called code, provide a set of precise steps for a computer to follow in order to accomplish a specific task or solve a particular problem. Programmers use various programming languages like Python, Java, C++, JavaScript, and more to write code. Each language has its own syntax, rules, and capabilities, but the fundamental principles of coding remain consistent across languages. Steps involved in coding. Steps: description, planning, understanding the problem, designing a solution, and breaking it down into smaller manageable components. Writing code, translating the planned solution into a series of coded instructions using the chosen programming language's syntax. Testing, running the code to identify errors, bugs, or unexpected behavior. Debugging involves finding and fixing these issues. Refining, optimizing, and improving the code's efficiency, readability, and maintainability. Documentation, adding comments and explanations to the code to make it easier for other programmers to understand its functionality. Iteration, continuously repeating the testing, refining, and documentation steps to create a robust and functional piece of software. Coding is a fundamental skill in the modern digital world, enabling the creation of a wide range of technologies that impact our daily lives. It empowers individuals to bring their ideas to life, solve complex problems, and contribute to fields such as software development, data science, artificial intelligence, web development, and more. Algorithm definition. An algorithm is a precise, step-by-step set of instructions or a well-defined procedure designed to solve a specific problem or accomplish a particular task. Algorithms provide a systematic way to solve problems by breaking them down into smaller, manageable steps that can be executed in a clear and organized manner. They are a fundamental concept in computer science and are used in various fields to solve complex problems efficiently. Input. Algorithm. Set of rules to obtain the expected output from the given input. Output. Characteristics of an algorithm. Here are the key characteristics that collectively define what an algorithm is and how it should be structured to effectively and reliably solve problems. Criteria. Description. Well-defined inputs and outputs. An algorithm takes one or more inputs, processes them through a series of well-defined steps, and produces a desired output or result. Clear and unambiguous. Each step of an algorithm must be precisely and unambiguously stated. There should be no room for interpretation or confusion about what each step entails. Determinism. The steps of an algorithm should be deterministic, meaning that given the same input and starting conditions, the algorithm will always produce the same output. Definiteness. The instructions in the algorithm must be well-defined and precise, leaving no room for ambiguity or confusion in their interpretation. General applicability. An algorithm should be designed to solve a general class of problems rather than being tailored to a specific instance. It should be adaptable and applicable to various scenarios. Non-redundancy. The steps of an algorithm should not duplicate efforts. Redundancy can lead to inefficiency and unnecessary resource consumption. Modularity and decomposability. Complex problems should be broken down into smaller subproblems, and the algorithm should be structured in a modular way, allowing these subproblems to be solved independently and then combined to solve the larger problem. Adaptability. Algorithms can be adaptable, capable of adjusting their steps or parameters based on changing input conditions or requirements. Correctness. An algorithm must produce the correct output for all valid inputs, adhering to the problem specifications and requirements. Traceability and debuggability. Each step of the algorithm should be traceable, allowing developers to identify and correct errors during implementation and execution. Termination. An algorithm must eventually terminate and provide an output, ensuring that it doesn't run indefinitely. Disadvantages of algorithms. Criteria. Description. Complexity. Developing algorithms, especially for complex problems, can be challenging and time-consuming. Ensuring that all edge cases and scenarios are considered requires careful planning. Expertise required. Designing efficient algorithms often requires a deep understanding of both the problem domain and programming concepts. This can make algorithm development inaccessible to individuals without the necessary expertise. Not always optimal. Not all algorithms are optimal in every situation. Some algorithms might be efficient for specific cases but perform poorly in others. Choosing the right algorithm for a given problem is crucial. Maintenance. Algorithms might need to be updated or modified over time to accommodate changes in requirements or to improve efficiency. Maintenance can be a resource-intensive process. Bias and errors. If algorithms are not developed with careful consideration of all scenarios and inputs, they can introduce bias or errors into the solution. Lack of creativity. While algorithms provide systematic solutions, they might lack the creativity and intuition that human problem solving can offer. Some problems might require unconventional approaches that algorithms might not easily handle. In summary, Algorithms are powerful tools for solving problems efficiently and systematically. They have numerous advantages, including precision, efficiency, and automation. However, they also come with challenges, such as complexity, the need for expertise, and the potential for errors. Successful algorithm development requires careful planning, testing, and ongoing evaluation. Flowchart definition. A flowchart is a graphical representation of a process, algorithm, or workflow. It uses various shapes and arrows to depict different steps, decisions, and actions within the process. Flowcharts are commonly used in fields like programming, engineering, business, and education to visually explain complex processes in a clear and structured manner. Advantages of flowcharts. Criteria. Description. Visual representation. Flowcharts provide a visual overview of the logic and flow of a program. This makes it easier to understand the structure and sequence of steps, especially for those who are new to the code. Simplicity. Flowcharts simplify complex programming logic by breaking it down into easy-to-follow steps and decision points. This is particularly useful when explaining algorithms or processes to team members or stakeholders. Clear communication. Flowcharts are a universal language that transcends programming languages. They allow programmers, designers, and other stakeholders to communicate and collaborate effectively, regardless of their coding backgrounds. Problem-solving. Flowcharts help in identifying errors and inefficiencies in a program's logic. By visualizing the flow, programmers can easily spot bottlenecks, dead ends, or missing steps. Documentation. Flowcharts serve as documentation for the program's logic. They provide an organized representation that can be referred to when maintaining or updating the code in the future. Planning and design. Before writing code, creating a flowchart allows programmers to plan the program's structure and logic. This helps in developing a clear roadmap before diving into the coding process. Disadvantages of flowcharts. Criteria. Description. Complexity. While flowcharts are effective for illustrating simple processes, they can become overly complex and difficult to follow for highly intricate programs. Complex programs might require numerous decision points and steps, leading to cluttered flowcharts. Limited details. Flowcharts might not capture every detail of a program, especially when it comes to complex data structures, specific syntax, or implementation details. It's important to complement flowcharts with proper code documentation. Maintenance challenges. Maintaining flowcharts alongside the actual code can be cumbersome if changes are made to the code. Updating the corresponding flowchart might be overlooked, leading to inconsistencies. Dynamic processes. Some processes in programming are dynamic and don't follow a linear sequence. Flowcharts might struggle to represent such processes accurately. Time-consuming. Creating detailed flowcharts can take a significant amount of time, especially for large programs. Balancing the time spent on creating flowcharts versus coding can be a challenge. Technical understanding. While flowcharts are designed to be accessible, understanding complex flowcharts might still require a certain level of technical knowledge. Symbols in flowchart. Symbols in a flowchart are graphical representations used to depict various elements and actions within a process or system. Here are some key symbols used in flowcharts. Function. Name. Symbol. An oval represents a start. An end point. Start end. A line array. Connector that shows relationships. between the representative shapes. Arrows. A parallelogram represents input or output. Input-output. A rectangle represents a process. Process. A diamond indicates a decision. Decision. It's important to note that while these symbols provide a standardized way to represent processes, the exact conventions might vary slightly between different flowcharting methodologies. Flowcharts can effectively communicate in a visual and intuitive manner, making them a valuable tool in various fields including software development, business processes, engineering, and more. Writing algorithm and designing flowcharts. Let us understand how to write an algorithm and design flowcharts for simple programs. Example 1. Write program to add to numbers. Algorithm. Step 1. Start. Step 2. Input num1. Step 3. Input num2. Step 4. Sum is equal to num plus num2. Step 5. Display the sum is sum. Step 6. End. Flowchart. Start. Read num1. Read num2. Sum is equal to num plus num2. Print sum. End. Example 2. Write program to display your name. Algorithm. Step 1. Start. Step 2. Set name is equal to your name. Step 3. Display my name is name. Step 4. End. Note, name is a variable. Flowchart. Start. Print. Enter your name. Input name. Read name. Print name. End. Vocabulary. 1. Programmers write code for computer programs and mobile applications. 2. Syntax. The system of rules for the structure of a sentence in a language. 3. Bugs. An unexpected problem with software or hardware. 4. Debugging. The process of identifying and removing errors from computer hardware or software. 5. Robust. Having or exhibiting strength or vigorous health. 6. Empowers. To give somebody power or authority to do something. 7. Unambiguously. In a manner that is not open to more than one interpretation. 8. Deterministic. Believing that everything that happens must happen as it does and could not have happened any other way, or relating to this belief. 9. Ambiguity. The possibility of being understood in more than one way, something that can be understood in more than one way. 10. Redundancy. An act or instance of needless repetition. 11. Modular. Consisting of separate parts or units that can be joined together. 12. Resource-intensive. Activities or processes that require extensive resources and energy. 13. Bottlenecks. A narrow piece of road that causes traffic to slow down or stop. 14. Roadmap. A map, especially one designed for somebody driving a car, showing the roads in a particular area or country. 15. Cumbersome. Heavy and difficult to carry, use, wear, etc. Let's wind up. Programming is the process of writing instructions in a programming language to create an application. Each language has its own syntax, rules, and capabilities, but the fundamental principles of coding remain consistent across languages. The steps involved in designing a program are problem definition, algorithm design, writing code, compilation interpretation, testing and debugging, documentation, maintenance and updates. Algorithms provide systematic and reliable instructions to solve problems efficiently and accurately. Complex algorithms can be difficult to design and understand, leading to potential errors and inefficiencies in problem solving. Successful algorithm development requires careful planning, testing, and ongoing evaluation. A flowchart is a graphical representation of a process, algorithm, or workflow. Flowcharts visually simplify complex processes, making it easier to understand and communicate the sequence of steps and decisions in an algorithm or system. Flowcharts can become overly complex and hard to follow for intricate processes, potentially causing confusion and hindering clear communication. Flowcharts use symbols like rectangles for processes, diamonds for decisions, and arrows for connecting steps to represent and illustrate the sequence of actions and choices in a process.